Kia ora. My name's Weiji. I'll be talking about GPU native Zarr. This was done in collaboration with some folks from NCAR and NVIDIA earlier this year at this open hackathon. So I'm just going to share some tips on how you can optimize your machine learning pipelines for if you're using Zarr in particular. So step one is I'm going to run through 4 steps. Step one is to optimize your chunking and compression. So if you're working using something like X-ray to read in, say, Era 5 climate reanalysis data, you want to chunk your data to fit your access patterns. So let's say your machine learning model is looking at one time step at a time. You want to chunk to make each chunk one time step long. General rule of thumb is you want your chunk size to be between 1 and 100 megabytes, give or take. And if you are reading the data over a network, it's usually a good idea to have compression. So something like ZAC standard or some other compression format. Pro tip is to use sharded Zarr if you want to save a lot on cloud object storage costs, because the more objects you have, the more you pay for get and put requests. So sharded Zarr is your friend here. Step 2, once you have your data sharded correctly, you want to optimize the read as fast as possible. So you can use, if you have Zarr Python 3, use a library called KivicIO or QuickIO, where this allows you to read from your Zarr file, Zarr store, directly into a QPy array. So you do that using the code on the right there. You set up this with Zarr config.enable GPU context manager, and then you load this Zarr store using quickio.zarr.gds store, and then have all of that there, and then your data would be loaded on the QPy array. So this, ideally, you would set up something called NVIDIA GPU Direct Storage. This can be a bit tricky to set up, but if you set it up properly, what you get is, you get to read data a lot faster than standard sort of CPU Zarr. Okay, so that's step 2. Step 3, I forgot to mention, with step 2, if your data is compressed, the data decompression happens on the CPU and not the GPU. So there's a bit of there's a bit of latency involved in that. With step 3, what we want to do is let the GPU do most of the work instead. So how this works is from the Zarr store, you send the compressed data to the GPU. You let the GPU do the decompression itself. GPUs can do this a lot faster than CPUs can. And then once the data is decompressed, your GPU can, you can carry on with your machine learning pipeline. So with the GPU implementation of using this library called NVComp, NVIDIA's compression library, you get a 0.2 gigabytes per second sort of speed up in terms of throughput compared to a standard CPU libzex STD sort of codec. So, however, this does still require this PR from Zarr Python, which has been sitting there for a few months now. So once that is merged, you can kind of use it. Otherwise, you want to install from that branch. Lastly, once you've kind of optimized the hell out of your pipeline, you want to make sure that you don't have the CPU or GPU be idle for too long. You can use a library called NVIDIA DALI, which handles this orchestration of have both CPU preprocessing, say you're filtering data or doing reprojection. You want to have that happen at the same time as the GPU is processing or doing the training run. So NVIDIA DALI kind of has that. We've had some code on that repo there. So this is the QR code, the slides. We wrote a really good blog post on this, and the code is in that repo. So check that out. I would again like to thank all of my collaborators from NCAR and NVIDIA, and also Development Seed for working on this. And my socials are there if you need me. And check out our booth at the Development Seed booth if you have any questions. Thank you.